Alright, today we're going to start with a problem that says use midpoint rule. And really all midpoint rule is instead of using those dots that are on the curve for the upper or lower sums, we're just going to find the middle of those and make rectangles from those. So the first thing I'm going to do is create those rectangles. And so what I'm going to need is I'm going to need the midpoints for each of these. And I am supposed to do it with subintervals of 4, so I'm making 4 of them. And notice what I do is I just make a rectangle of width 1, because that would create my subintervals of 4. My rectangles are a little off, by the way. They're not very straight. But you should get the idea. This is my height at where the midpoint is, and I'll draw those segments straight down. So what I'm going to do now is figure out the area of each of these. Now, before I do that, what I'm going to need to do is I'm going to actually have to plug in each of these values, which is going to take me a little bit of time, because I need to know the height at 1/2, at 3/2, at 5/2, and at 7/2. So I will do that off to the side here. So I'm going to be plugging in each of those so I can find the height. So I'll show you that right up here on one of them. So I'm going to do 1/2 squared plus 4 times 1/2. So when I plug in 1/2, I really end up getting 1/4 plus 2, which is 2 1/4. When I plug in 3/2, I would be doing 3/2 squared plus 4 times 3/2. This ends up giving me 9/4 plus, this would be 12 over 2, which is 6. Well, that's 2 1/4. So I'd have 8 1/4. When I plug in 5 over 2, I have 5 over 2 squared plus 4 times 5 over 2. 5/2 squared is 25/4. And I'd have plus 10. 25/4 plus 10 is 16 1/4. And the last one I have to do that for is 7/2. 7/2 squared plus 4 times 7/2. Equals, that would be 49/4, and I end up getting plus 14. Well, this is 12 1/4 plus 14 is 26 1/4. So now I have each of my heights, and I'm going to go ahead and box those in because I'm going to need those for my area of my rectangles. So now all I need to do is find the area of the rectangles. So the area is approximately, the height of the first one is 2 1/4 times 1, plus the height of the second one, 8 1/4 times 1, plus the height of the third one is 16 1/4 times 1, plus the height of the fourth one is 26 1/4 times 1. So this gives me an answer of 53 when you add those all together. I'll continue on the next video with the last 2 examples. In this problem it says determine which value best approximates the area under the region between the x-axis and the graph over the function over the given interval. Make your selection based on the sketch of the region, not by performing calculations. So this is multiple choice, and here's my multiple choice answers. I've got 3, 1, -2, 8, and 6s with solutions that are possibilities. What I need to do is sketch this graph from 0 to 4. My graph is definitely not looking the best right now. But what I get when I plug in 0 would be the sign of 0, which is 0. When I plug in 1, I have the sign of, maybe I'll do that over here, this side. When I plug in 0, I got 0. When I plug in 1, I have the sign of pi over 4, which is square root of 2 over 2. When I plug in 2, I have the sign of pi over 2. The sign of pi over 2 is, sign of pi over 2 is right up here, so it's 0, 1, so it's 1. When I plug in a 3, I get a negative, actually no, it'd be a positive square root of 2 over 2 because of the saying all students take calculus. Sign is positive in the second quadrant. And then lastly, when I plug in 4, I get the sign of pi, which is 0. So what it's going to do is come up, hit 1 right here. It's going to curve and then come back down. See if I can draw that in just a little bit better. So it's a curve that looks like this now. It's not very uniform, and it should be, but my drawing is definitely not very exact. So if I was to look at these answers, I would have to say that my best approximation, well, let's cut this up into some rectangles here. This one, this rectangle right here has an area of 1 by 1, which would be about 1. This is about 1 by 1, which is 1. And then these two together might be each a half. So I'd have to say that the best approximation would be A, 3. This next one, you need to ask me to do during class, because what we need to do is review how to use the table and use the regression capabilities of the calculator to find this equation. So please, please, please remind me to do this with you in class. If you'd like to, it'd be good for you to try it on your own to see if you can remember how to do it, but if not, I'll review it in class.